Okay, let's start. So you have plenty of time to download the notebook. The goal is to try to redo everything that I will be doing. Of course, I will explain each piece of code, but the goal today is to try to get a grasp about two libraries. I don't know if we will have time to do both because we start a bit late. So the two libraries are itertools and joblib. So itertools is a library for iterators, and it can create pretty complex iterators quite simply. And joblib is another library to use multi-processing or multi-threading in your program and collect the result in a very simple manner. So let's start. So I'm going to run everything to make sure all is good. So the first function in itertools that I would like to mention is count. And count is simply an infinite iterator that can start from some point and there is a step. So in the first case, there is a usual range function, okay, that you all know and love. And if you try to do it with count, you will get surprised that it's infinite, so it does not stop. So it would create an infinite loop if you execute the commented code. So instead, what you need to do is, if you want to stop at some point, is to put some kind of test inside the code. Okay. So here, the two loops do more or less the same thing. So, okay. So far, not very impressive. I don't ask you to be impressed. What they claim, if you look at the documentation of itertools, is that it is faster than Python. So if you write the loop by yourself, they claim it is faster. They claim it uses less memory because when you have a range, it creates a full data structure that you iterate over. While in itertools, you have only the iterator and you do next. So I try to do the same as before, okay? Except that instead of iterating over 10 values, I iterate over, 10 million. Let's see what is going on. So if I execute, okay. So of course the numbers are going to be different on your machine. It seems that the running time is not necessarily significantly smaller when you use this like this, okay? But of course, that is because we are mixing itertools, count function, on some Python if inside the loop, okay? So when you start to mix functions from itertools that are written in C with Python code, it's not necessarily faster. Now the interesting function is the interesting function is islice. So islice is like creating a sublist when you use the subtracting in Python for tables. But here it is for iterators, okay? So I try to run, the same code with a range function and we add it to a list. And now I use the count and also isLice to say, okay, whenever you reach 1, you stop. So you don't do the test at each iterator loop in Python. You use a function that internally is coded in C to use with the other loop. Okay. And when you run that, then you can see that the running time is much smaller than the classical loop with range and everything. So numbers will be different on your machine, but
I have 0.
You have 0?
Yeah.
Okay.
So it's good.
So it is indeed much faster. So when you don't use a Python flow program command within the iterator loop. So far, so good. So then, okay, there is a question in the chat. Muter ton micro. Moi, je veux bien muter mon micro, mais...
En fait, on a un écho.
Alors, attends. Qu'est-ce qu'il dit?
On l'a à la fois par Amphis et par Sébastien.
Voilà.
Et là?
Nous, on n'entend rien, en fait.
Vas-y, parle.
Do you have echo still?
Non, là, c'est bon.
Okay. Let's continue like this. Okay. So another function that can be interesting is itertools.chain, which is going to chain iterable sequences. So it means that, okay, if you have several iterators and you want to go one sequence after the other, you can use a chain to do exactly that. So here we have an example with a list, with a tuple, and with a string. And I can chain all of them. And when I execute, it looks like, well, one sequence, etc. So you collect results from many iterable sequences. Then you could group them together in a single one. Now there are 3 functions that are more or less interesting. So cycle is going to cycle through the elements of a finite sequence infinitely. To just repeat the sequence. Repeat will repeat a given element n times. And change from iterable is supposed to receive an element. And then this element is supposed to be itself an iterable in order to iterate on it. So one example is here itertools change for iterables from itertools repeat. So I get the list that contains the number 1 to 9 10 times. Yes. But since each element itself is a list, it is iterable. So you can chain it this way. Just some syntactic sugar. Okay, perhaps since during the last PTT, I think we mentioned about filters and functions as parameters. There are a few in itertools function as parameter. One of them is filter false. So filter false takes a predicate on the sequence, and if the predicate is invalidated, then the new sequence is produced for each element that does not satisfy the predicate. So here I took the same list as before. I construct the same big list as before. And there is a filter false with a parameter that is a function. And that checks if the element is strictly smaller than 5, or if yes, well, the element is not output. If false, then the element is output. I don't know why we choose the filter false instead of filter true. It is how it was implemented.
Je pense que je ne sais pas si les sons de Sébastien, les sons, les micros, mais les sons.
Là, on est coupé. Okay, but now I try to check again if filter false is more efficient than what we could write in Python. So in the first loop, I get all the 1 million values, and if the current item is greater than 4, then I append, etc. And otherwise, there is a filter false on different manners to implement basically the same thing. So one is change from iterable on repeat, as we saw before. One is slice with a cycle. And the last one looks like the same. So maybe I just put it a few times, but it was not necessary. Okay, and when you run it, okay, so this one.
Difference between 2 and 3 is that you do not append the list where you do the.
Oh, yes. So
So the last one is fast.
so the last one is with the list constructor, while the final one is by appending etc. So the reason I add the last one is because, well, I was surprised that the difference is not so big between the classical Python and the itertools with the filter false. So one way to improve a bit is to really try to remove as much Python code in each iteration as you can. If you do that, it is indeed faster. It should be faster also on your machine. Okay?
But not a so big difference.
No, not so big. Not so big. So probably when you pass a function as parameter, well, the function is still Python program, so you don't gain so much.
The first one is the fastest.
For you?
Yes, but maybe if I run it.
For me, it's capital 7.
But I'm running on Google Cloud, so there is.
Okay. Interesting. Okay. So one that got me very excited is a group by. Okay. So group by is a function of itertools that is going to group the result according to some criteria. Okay. So, for example, in the first example, you have a data with 1, 1, 2, 2, 3, 3, 3, and you would like to group it. So by default, the grouping key is the identity function. So it should be grouped by value. So when you run it, you have for the value 1, you have 2 elements. Value 2, 2 elements. Value 3, 3 elements. Okay. Very nice, very good. So you could say, okay, I will group using a function that returns the length of the word. Okay, so then with the words of 5 letters, there is one word apple. 6 letters, banana and cherry, 4 letters, 3 letters, 5 letters. It all goes pretty well. So let's continue. Let's sort by first letter. And group them by first letter. It works well. The words start with A, etc. And then, okay, let's try something maybe more elaborate. Let's try to classify the numbers as odd or even. Okay, so the function here that is submitted, if the number is, no, it's the contrary. Well, sorry, yes.
I don't get the group by len because there is two. So there is apple and len that is of the same length. Maybe I miss something.
Apple and grape,
Great.
yes, absolutely. So you already noticed that there was a problem. Up to that point, I didn't see the problem. I saw the problem from this way. But you are right, there is already a problem in the previous one. So it does not really group by. So I'm going to run this one as well. So, okay, even and odd are reversed, sorry.
Here we see that there is a problem.
Yes, so here, clearly we see that there is a problem, okay? 1 is odd, 2 is even, 3 is odd, okay, but they are not grouped. Okay? And actually, if you read the documentation of the group by, they say that the input sequence must be sorted according to the same criterion. So here you can see that the numbers are not sorted with the same criterion. Okay. So they are just increasing sequence number. You don't put first all the even and then all of the etc. So the solution is to, well, first sort. So here there was another problem. So here the names are no longer in alphabetical order. Same thing appears. The grouping does not occur as it should. So the solution is to sort the values before you use the group by. Okay, so I thought it was magical, but no. So you still need to sort it, so there is no free lunch on this one, but still it can be interesting. Okay. So sorted data, you just use the sorted function and you supply as the sorting function, the same one that you use in the group by afterwards. And then apple, banana, and etc. And then all the outputs are as expected, the even numbers, the odd numbers, the first number, etc. So if you sort according to the same key, the same comparison function before you use the group by, it will work as you initially thought it would work. Good. So far it is okay, convenient, but maybe not that impressive. But what I find it very useful for is when you try to iterate over combinatorial structure. So, for example, to try all possible combinations of simulator, and then run the experiments for each set of experiments and collect all the results for all the possible values. So, a combination of n elements among some items is all the possible choices for getting an element out of a sequence without considering the order of those elements. Okay. So the first example is this one. Okay, so you have 4 elements, A, B, C, D. So you could have A and B, A and C, A and D, B and C, B and D, C and D. And it's going to output all of them for you. And then, of course, you can iterate over this sequence because it's given as an iterator. So now you could say, yes, but you can do it very simply. Okay. Just write a for loop and make sure each time I run into the nested loop that, okay, I will only consider the indices that are strictly greater than the previous one. It will give me easily all the possible combinations. It's not so much of a big deal. Now, if you run it, so in this example, the number of elements is 26, and the size of the combination subset that we want to generate is 3. So if we run it, yes. It's actually not faster. Maybe. So if we run it again, so here, this one is faster. So perhaps you would need to run it a few times, but it's not really faster so far. However, if you increase the number of elements,
For me, it was 100 faster.
yes, yes.
It's on the architecture, the C compiler, because it's in C, the magic is
Yes,
that some part is
yes. So, but now look at this code, and you can see. So I just with the itertools combination set, just change the 3 to 6, 6 elements. Well, in the other one, well, I have to write 3 more loops here, and upon the various combinations. So now when I run it, okay, it is still not faster. This one is faster. This one is faster. So some degree of speed, better. Okay. But it is much easier to write, or it is much easier to get it right. Okay, now a bit more funny. How to generate all the permutations. So permutations are like the combination, except that the order of elements is important. We want to have this one first, then this one. If you run that, okay, symbol orderings. So here it is quite faster. And actually, when we try to get to 6, so then it can get a bit longer. So I've put a warning saying that it may take 1 minute 30 seconds. It depends on the laptop or on the machine.
It crashed.
It crashed? Okay.
And then, I will do it now. Better.
So, well, yeah, when there is a warning, you don't need to run the cell to be completely completed.
The workload crashed after using all available runs.
Yes. Okay. So, in the previous runs, what I got was, yes, about 1 minute, 30 seconds. Now I am on battery, I hope it does not crash. But for the permutation of the set, it's factorial in the size of the set. So factorial gets big pretty quickly, so going from 3 to 6 is going to be quite a strain on the memory. Oh, okay. So is itertools, it took 6 seconds and 76 seconds without. Okay, so here the gain is quite significant. And the last one I wanted to mention is the product. So product is Cartesian product, so a possible combination of everything. So this one is exponential in the size that you are trying to get. So it is even worse. So Cartesian product. So when it is small, it is not that, etc. So here, this one, on my machine, it takes more than 10 minutes, so I will not run it. But on some older machine, it took more than 2 hours. So because there is inner item, because already the itertools one takes maybe 1 or 2 minutes, and the other one takes much more. So overall, okay, what is good about the itertools is it's supposed to be memory efficient. So if you don't use all the Python inner loop, you should not get for those tasks memory exhaustion. You don't have all the ranges. The code is simpler. After some mind training that okay, you write everything in one function, possibly calling another function and avoiding Python code of each iteration. On performance, so it is often faster, not always, especially for some small samples. All right. So now, exercise time. So let's say that you have a website that wants you to write a password. Okay? But they put some constraints on the password because they believe that if they put those constraints, the password will be harder to guess. Okay? So the constraints are the following: at least 1 uppercase letter, at least 4 lowercase letter, all different, at least 2 digits, at least 1 special character among plus, minus, equal, underscore, arrobas, and sharp.
But there is one condition missing. Like the size.
Well, the size should be at least 8 characters. Okay. And now, as you know, because you are a user of such website, it is very human to try to satisfy the various conditions the quickest possible manner. So first you write a capital letter, then you type 4 single-digit characters, then you type 2 numbers, then you type a special character and hit enter. Because you have the JavaScript that checks, you have all the checks, and then your password is accepted. So write a program that enumerates all such passwords, assuming the user satisfies request as quickly as possible. And then second question, is it better or worse than a password with no constraint? Just 8 characters.
Better or worse in terms of,
Well, in terms of security, password is for security.
and this is where I have a problem, because if you don't fix the maximum amount of characters, theoretically, both ways, you could get an infinite password and they have the same strength.
But the hypothesis is that you are lazy, so you do.
Yes, the hypothesis is that you are lazy.
So you stop at 8.
Yes.
Okay, yeah.
And you do it.
Now
What
it
is
works.
important is that you do it in this order.
Yeah, but now it works when I have this problem with the fact that the password can go on and on and on and on. And if it is.
Okay, I will add the line.
Sorry.
No problem. I give you 5 minutes.
I do not have to write.
We know the
I know
answer.
the answer.
You know the answer?
Yeah. Because if you have no constraint, this embed what you do with the constraint. So.
Oh. You know the answer to the second question.
Yeah,
Sébastien?
for the second question. It was the most important one.
We got stuck on the second question.
Okay, I will show you.
What may be interesting is just using only lowercase letters. We may have an answer that is already. I don't know. I need to do the calculation. Because here, using special character is something that we avoid generally also.
When you request to use a special character, you significantly decrease the number of characters.
No, but if you do not request it, you don't do it.
It depends.
I'm lazy.
So online, any proposal? No? At what time do you observe like?
In 15-20 minutes.
Can you try partition products? Partition products, partition vectors? So I can show you what I did. Where is it? Exercise. Okay, here is one proposal, not claiming that it is the best. Okay. So I have one set of uppercase letter, one set of lowercase digits on special characters. And the passwords are going to be, so I don't know if you're familiar with f-string in Python. So f-string is a formatted string. And then within each brace, you can put variables or even functions. Any game changer because there is one single element and you put everything inside. So this is going to construct a string that contains u, the variable u, that contains the empty string with the join of a list, L, an empty string with the join of another list, D, and then the string S. Okay? And then I just detail all the sub-elements of the string. So the first character is one uppercase letter. The second is a permutation, because order is important, of the lowercase letter, and I want 4 of them. Then I want 2 digits, whatever they are, so it is a product with digits and digits. And S is just a special character. So that will give me the password. So then, for E password, in enumerate the password. So enumerate, I don't know if you're familiar with this function. It's not an itertool function. It's just a function that lists everything and that puts integer counter together. So just to have the number if you are really busy. So here I do a break after 10 password. And then I do some little bit of calculation to compute how many passwords there are. So one way to do it is to sum over every password. So I did it, but it takes a while. If how many are generated, but at least it permits to know that the next computation is correct. Or you can say, okay, how many? So 1 uppercase. Then I choose 4 elements from a set of 26 of permutation. So the formula is factorial n over factorial n minus the size of the set. Then 2 digits. Then 6 possible special characters. While otherwise, well, you can use capital letter, lowercase letter, digit, special character, and you put 8 of them. And when you run that, so with the constraints, you have this many passwords. Without the constraints, you have this many passwords. So it's at least 5-digit difference.
But if you do over 26, if you just use lower letter, you can do the calculation and maybe it will be, I don't know. Just add because
You're curious, so
Yeah, yeah.
let's do it. It is still better.
It's still better. No, but I cannot do by Natalie.
Yeah, okay. But it's better assuming that people select random character, which is
Yeah, if you
select
if
Saju,
you select
Andrea,
if you select a word of 8 letters that exist
Yeah, but
Okay.
still you have a very high probability with small set there. So
yeah.
yes, of course.
So be careful with your policy.
But if you here you do not take into account the order, if you don't respect the rule of the smallest, so you need to here what you say is that
you need to do all the
yeah, the permutation. You can do the calculation, but you need to calculate. You just need to write.
I think if you do the permutation, it works because it forces people to put numbers and special characters, and so the total.
But of course, it anyway, the last question, not the last one, but that I did, but the last one, you cannot do better. On 8 letter. Right, so,
Okay. So now we are starting the overtime period, but as long as the pizza has not arrived, let's continue. So the second library I would like to mention is joblib. So joblib is a library for parallel computing, but also caching and serialization. Okay. So if you follow the previous Python workshop from Biggs about threads, you know that threads have quite a big problem, which is the global interlock
that exist between the threads that prevents to use multiple cores or processes at the same time. So threads are very good for input-output constrained tasks, so such as a web server or something. But they are very bad at improving the computation time when you have several. Okay. So when you have several cores, there is another very old or very well-known library called multiprocessing that works fine. Okay. But joblib does more or less the same as both threads of multiprocessing. And actually, you can choose what is the backend that you want to use, depending on your project. You need to be careful, though, because when you use the thread backend, the variables are shared between the threads. In particular, if you give a NumPy array as parameter on the thread, you modify the NumPy array. The NumPy array is shared between all the threads. So it can be surprising sometimes. While if you use the multiprocessing or default backend of joblib, the variables are duplicated for each process. So they are in some sense redundant. So you get a copy. So if you modify it afterwards, then you only modify your own copy.
You have like deep copy or clone inside the joblib,
Yes.
only if you call it with the.
Yes, well, it creates some process. So it's somehow it duplicates that for the model. So the syntax is actually quite simple. If I run this code, so the code is not particularly interesting. So joblib parallel means, okay, run in parallel. And then you can see that there are two sets of parentheses. The first set is how many cores, how many processors do we use? So how many parallel times do we run the function? Here I put -1, which means use all core available. Usually that's what I do because it is simpler. And then you have the joblib delayed, which just means that the function is not executed immediately, but it will be executed within the process that is launched by the joblib. And the function we are going to use is square root from the bat library. And then comes the parameter that is going to be passed to the function. So here I to the power of 2. And you can have some for loop with some iterator here. So here it says the line I wrote in parallel with as many cores as possible. The function that does the square root of the parameter put to the square for the numbers from 0 to 9. Okay, so it returns the number. Oh, okay, there is a question. Leonardo. So that's what I explained. So the default backend of joblib is to have processes, not threads. So there is no GIL in this case. But if you use the thread backend, so you can do it in two different ways. If you look at the documentation, with condition, with backend equal blah blah, then you can use the other one. But if you use threads, you will have the GIL problem. Okay, 7. Okay, thanks. Okay. So okay, so the second example is more or less the same. Instead, now it's a list. The function takes some time. Well, so what I find particularly convenient is that the parallels construction returns a list of results. And each result is a result of a process that executed the function. to collect all the data from many experiments. Suppose your function runs a simulator for 1 hour. Okay, you could run 10 times the simulation and collect the value only the same. And, no temporary files to adjust or things like that. It's quite interesting, I think. So we already saw some kind of caching during the functional TTP. Here, there is more or less what happens if a job crashes. That's a good question, and I don't know. I don't know. Thank you. Okay, so memory caching. Memory caching. So you specify a cache directory, and you say that okay, your memories that you are going to cache the result of functions that are specially marked in some file. Okay. So here I have a very complex function that computes the square. Okay. And I have the decorator memory cache, where memory is related to the cache directory I specified above. So when I run it, the first time it is used with 5, it is computed. But the second time it is not computed, it just returns the results. It's same for 10 or etc. So the good thing is that the caching works among processes. So all the locks on the file in order to get the cache, retrieve the cache, it is all managed. It would not be a good TTP session without the Fibonacci function. So I propose two versions. One is iterative, one is recursive. Okay. I don't quite remember how much time it takes to run yes, okay, 10 seconds. But if we use the cache, so here I only change the memory cache decorator above each function. So I do the same. And now it is quite faster. So recursive is still 10 times lower, but the result was almost instant. And if I do it again, well, now it's about the same. Because everybody has a cache value now, so if I rerun it, it's already stored somewhere in the cache. So I don't need to. It's not the case. Not for you? For the level, it's the factor of more. Okay. Interesting. So then they claim that they have a very good serialization service for large data. So typically AI model or big NumPy files. So you can use dump on load in order to store the data you're interested. Oh, does not work. Oh yes, I changed something. Sorry. It says it's the same. And they claim it's faster than Pickle. I was a bit suspicious. So I wrote this cell. And yeah, it is a little bit faster. Okay. So we claim that if it's very big, then it will be much faster. It's believable, but it's not 100% reproducibility. So joblib is quite interesting for running in parallel many times the same task. Okay, so when you don't have to have a very tight communication like with the queues or etc. between the threads, etc., when the jobs are purely independent, as it is the case when you are running a single-threaded simulation, for example, when you want to collect the result, then using joblib is very great. You can cache the result of the value between the processes. So after a while, many of the function results could be cached, so it can be efficient. Serialization, I didn't see yet if it's really improved or something else, but at least the logs are managed. And the API is quite simple, frankly. Because when you want to do the same with threads, so first you have to pass parameters that are shared by all the threads to retrieve the result. So by default, the thread returns no result. And also you need to always have a loop, launch the thread on the loop, wait that all the threads are finished before you can get all the results. Here you get everything in one line. So I find it more convenient. And then I put, well, actually, I asked ChatGPT to generate four examples where you use both itertools and joblib to try to mix the two. So this is some of the proposals that I got. So one is to have a list of 1,000 and get all the pairs and run a function about all the pairs in as many parallel jobs as possible. So as you can see, the code is quite straightforward. And it can run quite fast, even if there is a very big number of processes. Yeah. Second use case is, okay, so you generate all the possible inputs using itertools. For example, for all permutation, okay, run some particular function. And use joblib as a memory cache for all the values. Okay, quite fast too. Sometimes you may have an infinite sequence. So if you collect data from an external source, for example, or from, I don't know, a key shark that returns a lot of pickup from the network, you could say, okay, every time you have collected this many packets, run this algorithm over this thing. So here, with the eSlice, you can actually slice the infinite string you're getting in some batch size on which you execute in a separate kind of protocol. And the last one is for, oh, okay. Is it possible to control the execution of parallel jobs? The execution order is not guaranteed because they run in parallel. So you don't know which one will be faster. You don't know anything, and you have no control over it, as with everything that is parallel. Was a question and so the last one is for the people that like to do AI. So here, typically, when we have to select which parameter provides the best accuracy, for example, Well, you would typically write a loop where you test all possible combinations of parameters on the model, maybe catch the result, etc. And finally, get the information that you want. So here, it's running. Okay, model scores. Okay. So here you can see, so what, for each model, I am returning a tuple with the parameters and then the score, okay, because it's what I'm interested in. And with the result I get, I just sort according to the second parameter, which is the score. So I get the highest score for the parameter 702. You can see that the code to get the score, it's really a one-liner, okay, delay, train model. You can put all the parameters directly in parentheses. You can iterate over some iteratable sequence. It is all run. It is all, you get all the results in the list. And then you can process the list, whatever you want to draw, every kind of curve that you want.
For machine learning, there is a library that is also called with search. Let's see. But yeah.
So here it's not only for machine learning.
Exactly.
If you want to run a classical simulator, you can also have the first parameter, all the parameters of the simulation, the result, run it 10 times, and collect everything with the group by. And then maybe there is another question I did not see. Is there a new question? I did not see.
It was just a sense.
Okay. Okay. Well, that is all I have for you today. I think the hour of the starting time, so on the village should be in arriving, but they are right.
So thank you very much.